Hello all. This presentation we are going to discuss some important questions in image processing. We are going to discuss the questions in two parts, part A and part B. Part A are short questions and part B comprises essay type questions. Question number 1, explain the terms path and path length. Now for this we have to consider two pixels P and Q, and we know in between there are pixels, and if we are able to establish some kind of adjacency across the pixels that lie between P and Q, we can say that there is a path from P to Q, and N will be the path length. So to understand this better, let us go to an example directly. So here is a sub image of size 3 by 3. Now the two pixels P and Q are the one that are shown here. Now given V equal to Z1. So we are able to establish M adjacency between the pixels that are connected by dot line. Now there is a path as we see from pixel P to Q. And here the path length is 3. Let us go to question number 2. Distinguish between spatial domain and frequency domain in image processing. In spatial domain techniques, the pixels are converted to whichever value that are required in the output image and directly. Whereas in frequency domain techniques, the pixels are taken in a group and they are transformed using a transform mechanism. For example, a Fourier transform or a Euler transform will be applied, and upon the coefficients, the further processing will be done in frequency domain techniques. Now there is a expression to represent the spatial domain techniques in general. Let the image be fx, y and t be the operation. When we perform the operation over the pixels in the image, we get the output gx, y. Question number 3. What is chessboard distance in a digital image? Now for that again we have to consider two pixels P and Q. Let us assume that the coordinate of pixel P is x, y and coordinate of Q is s, t. The chessboard distance or DA distance is given by the maximum of modulus x minus s, modulus of y minus t. Please note, there are other distance measures also. Euclidean distance given by the formula. Another one, city block distance given by the formula. And the third one is the one we have discussed just now, chessboard distance given by the formula we see below the heading. Question number 4. What are the disadvantages of Wiener filter? So f cap is the restored image given by the equation, and in this equation h is the degrading function and the terms sf and sn are the power spectrum of the image and noise respectively. Now the disadvantage is that what is common to all, and that is we should have an idea about the degrading function h, and the overhead with the Wiener filter is that we should also know the power spectrum of the undegraded image and the power spectrum of the noise. They must be known. So that is the addition of it when we come to Wiener filter. Question number 5. What is pseudo color image processing? This is artificial coloring, and in this different intensity values are assigned different colors. For example, we can assume that intensities from 0 to 50 is assigned a color, say C1, and 51 to 150 is assigned some other color, say C2, and 151 to 255 can be assigned a different color, say C3. Now in the pseudo color image processing, in this case, will deliver as a color image having 3 color representation, namely C1, C2 and C3. Question number 6. Compare and bring out the difference between image enhancement and image restoration. Image enhancement is a process of making image more useful. So we basically remove the noises and we highlight the features that are interesting. That is being normally done for enhancing the image. Whereas in image restoration, we try to restore the image, or we try to repair a degraded image. Question number 7. Bring out the difference between JPEG and JPEG 2000 compression. So JPEG 2000 is one of the recent compression technique, and the advantage is that it is more efficient compared to JPEG, yields an image with a higher image quality. And if we compare the techniques that are used, JPEG relies on DCT technique, whereas JPEG 2000 uses DWT for transform operation. And also in the case of encoding, Huffman encoding is used for JPEG, whereas arithmetic encoding, which is much more efficient, will be used in JPEG 2000 coding standard. Question number 8. What is histogram? What information it gives? By definition, histogram of an image is a plot of number of occurrences of a gray level in an image against the gray level values. So we have to see how many number of pixels against each gray level, and if we make a plot of that, we get the histogram. So here is the example. So in the x-axis, all the gray levels will be marked, and the count of each gray level will be represented in the y-axis. So that is otherwise known as frequencies. And the kind of information that you get from the histogram is that it will show us the distribution of gray levels in the image. So we can see how many number of objects are present. So it will be segmented. So massively used in image processing and especially recommended in image segmentation. Question number 9. What are smoothing filters? Explain. Now, smoothing filters are the averaging filters, and they are used for removing noises. So a mask is shown here. So a 3x3 sized mask is shown as the example with weights 1/9 per cell. So when we sum up all of them, it will become 9. Smoothing filters are also known as low-pass filters. They are used for reducing noise and for eliminating small details. And we can also observe that if we add the elements in the mask, they will sum up to 1, and all the elements are positive as well. So, question number 10. Explain run length encoding as used in an image with an example. In run length encoding, we will compress the image details into just 2 bytes, namely symbol, comma, count. 2 examples are given. First is a string of ones and zeros. When it is compressed, we have the symbol followed by count. Initially there are 5 ones, so it can be written as 1, 5, followed by 6 zeros, so that could be written as 0, 6. Then an odd one represented as 1, 1. Example number 2 that uses symbol A, B and C. So we can see how it will look like when it is compressed by run length encoding. Now this run length encoding is used in bitplane coding. In bitplane coding, the image pixel will be converted into 8 planes, namely B0 to B7, and per plane we can apply run length encoding because in each of the plane the data will be in binary form. So very efficiently run length encoding can be applied in a plane. Question number 11. What are sharpening filters? Now, sharpening filters are otherwise known as high pass filters. So the weights, there will be positive as well as negative weights present in the mask. Example shown on the right side bottom. -1, -1, -1, -1, 8, -1, -1, -1, -1. So when all the terms are added up, we will get a 0. Few more details on sharpening filters. They are used for removing blurring from images, used for highlighting the edges. Sharpening filters are based on spatial differentiation, and one common example for the sharpening filter is Laplacian. So here is the mask for the Laplacian filter. We have the formula for delta square f, and from that we can deduce the mask 0, 1, 0, 1, -4, 1, 0, 1, 0. Question number 12. Explain the basic operations in digital image processing. There are 5 basic operations: image acquisition, pre-processing, segmentation, representation and description, recognition, and interpretation. You need to elaborate each of the points. Wishing you all the best for the exam. Thank you. Bye-bye.